In a previous lesson, we found the divisors of some small numbers. Now, when the numbers are small, it's easy to find their divisors. For example, we can see that 3 is a divisor of 12, 5 is a divisor of 35, and 6 is a divisor of 42 just by looking at the numbers. But what about larger numbers? For example, is 3 a divisor of this number? In other words, is 20,012,441 divisible by 3? Well, it's hard to tell. We could divide 3 into this number to find out if there is a remainder, but this would take too long. A faster approach is to apply some useful divisibility rules, which we'll learn in this lesson. We'll begin with the divisibility rule for 2. Now, if a number is divisible by 2, then the units digit of that number must be 0, 2, 4, 6, or 8. So, for example, 2 is a divisor of these numbers since the units digit of each number is 0, 2, 4, 6, or 8. Conversely, these numbers are not divisible by 2 since the units digit in each of them is not 0, 2, 4, 6, or 8. Okay, now let's examine the divisibility rule for 3. This one is a little trickier. To determine whether a number is divisible by 3, we must find the sum of its digits. If the sum of its digits is divisible by 3, then the number itself is divisible by 3. For example, 3 is a divisor of 10,023, because if we add all of the digits, we get a sum of 6. Since 6 is divisible by 3, we know that 10,023 is divisible by 3. Similarly, this number is divisible by 3. When we add its digits, we get a sum of 21, and since 21 is divisible by 3, we know that 708,042 is divisible by 3. Finally, 2,817 is divisible by 3, since the sum of its digits is 18, and 18 is divisible by 3. Conversely, 23,401 is not divisible by 3, since the sum of its digits is 10, and 10 is not divisible by 3. Similarly, this number is not divisible by 3, since the sum of its digits is 25, and 25 is not divisible by 3. To determine whether a number is divisible by 4, just look at the number that is created by the last 2 digits. If that number is divisible by 4, then the entire number is divisible by 4. So, for example, 4 is a divisor of 60,012 because the number created by the last 2 digits is 12, and since 12 is divisible by 4, we know that 60,012 is divisible by 4. Similarly, this number is divisible by 4 because the number created by the last 2 digits is 36, and 36 is divisible by 4. Finally, this number is divisible by 4 because the number created by the last 2 digits is 0, and 0 is divisible by 4. Conversely, 35,014 is not divisible by 4. Here, the number created by the last 2 digits is 14, and 14 is not divisible by 4. Similarly, this number is not divisible by 4, since the number created by the last 2 digits is 73, and 73 is not divisible by 4. Next, we have the divisibility rule for 5. This one is very straightforward. A number is divisible by 5 if the units digit is either 0 or 5. So 5 is a divisor of these numbers since the units digit of each number is either 0 or 5. Next, we have the divisibility rule for 6. If a number is divisible by 6, then that number must be divisible by 2 and by 3. For example, 6 is a divisor of 10,032. We know this because the last digit of this number tells us that the number is divisible by 2, and we also know that this number is divisible by 3 since the sum of its digits is 6, and 6 is divisible by 3. So since 10,032 is divisible by 2 and by 3, we know that it must be divisible by 6. Similarly, this number is divisible by 6. Its last digit tells us that the number is divisible by 2. And since the sum of its digits is 21, we know that the number must be divisible by 3, since 21 is divisible by 3. Conversely, 6 is not a divisor of 77,032. Although the number is divisible by 2, it is not divisible by 3. We know that it is not divisible by 3 because the sum of its digits is 19, and 19 is not divisible by 3. Now, there are divisibility rules for 7 and 8, as well as for other numbers, but you will not need them for the GRE. Next, we have 9. The divisibility rule for 9 is similar to the divisibility rule for 3. If a number is divisible by 9, then the sum of its digits must be divisible by 9. So this number is divisible by 9. The sum of its digits is 18, and since 18 is divisible by 9, we know that 761,022 is divisible by 9. Similarly, this number is divisible by 9. The sum of its digits is 9, and 9 is divisible by 9. This number is also divisible by 9 since the sum of its digits is 27, and 27 is divisible by 9. Conversely, 23,401 is not divisible by 9 since the sum of its digits is 10, and 10 is not divisible by 9. Finally, we have the divisibility rule for 10. This one is the easiest. A number is divisible by 10 if the units digit of that number is 0. So 10 is a divisor of these numbers since the units digit of each number is 0. So these are the divisibility rules that you need to know for the GRE. Be sure to memorize them since they often come in handy.